Well, good morning. It's always a pleasure to be here, and I can't say enough how wonderful you did. And bye, Karen. It's not personal, I hope. So Karen asked me to give you a presentation about the ABCD1 variant database, which was previously called mutation database, but we now talk about variants instead of mutations. So these are my disclosures. I don't really have anything to disclose. So if we talk about genetics and ALD, I think we really have to start in 1993 when Patrick Aubour, he has been at LXTLC several times in the past, when his group identified the ALD gene. They worked on this project for several years, and I crossed out the word putative because the journal Nature didn't believe that this was the gene because they were anticipating a gene with another function, so they made them put the word putative in there, but it was really clear this was the gene. And to give you an idea how incredibly difficult it was to find this gene, I like to give you some information. Our human genome contains 3 billion nucleotides, building blocks. And the ALD gene is located on the X chromosome. And the X chromosome is built up of 156 million nucleotides. And the ALD gene only covers almost 20,000 nucleotides. So this is like 0.00062% of the entire human genome. And to put it in perspective, it is like finding one person in a group of 160,000 people without almost any knowledge. To give you an idea how difficult this was to find this gene. But they succeeded in doing that, and that really changed the ways that we had for diagnostics and research. So as I said, it was in 1993, the gene was identified. And then many groups worldwide started looking for genetic variants in this gene. And that resulted in a huge number of mutations, of publications in the years thereafter. More than 50 publications were put online, and they all reported patients with variants. And what was striking, first of all, what's really important, that all ALD patients had a mutation or a variant, a pathogenic variant in this gene. So that really confirmed that this is the only gene for this condition. What also was clear is that there was really a high number of different variants. Almost all families had their own personal or private mutation. And what also was important to find out is that these mutations do not correlate with the clinical outcome, meaning cerebral ALD, spinal cord involvement, or adrenal insufficiency. And what was also striking, that within a family, by definition, everybody has the same mutation because it's inherited. But within these families, we could see males with very different clinical outcomes. This is shown here in a paper from Johannes Berger from Vienna in 1994. This is a very large pedigree, and all the squares are males and the circles are females. And all the squares in black are affected males. And these are some old abbreviations, but there was a man with spinal cord involvement, a male with only adrenal insufficiency. There were some that developed cerebral ALD in childhood, and some developed cerebral ALD in adulthood. But they all have the same mutation. So that means that if you know the mutation, it does not have any predictive value. So as I said, there's a very high number of mutations, and I started to collect these mutations, and I was at that time already working in Amsterdam, and we performed a lot of diagnostics in Amsterdam. I collaborated with Baltimore. They also had a lab that did diagnostics, and in Paris, the group of Patrick Aubour performed diagnostics. In 1995, I was invited to come to the United States to do my PhD, together with Kirby Smith and Hugo Moser. And I was collecting all these mutations, and I mean, this was previous millennium. So the internet was just starting. And one day I said to Professor Moser, I said, well, wouldn't it be nice to put this on the website? And then he said his, for me, famous words, yes, Stephan, I think that's a very good idea. I support you. I mean, it was in the 70s. I mean, the internet was as new for him as for us, but he already understood the potential importance of this. So I started, not without any knowledge, I started doing this, and the first thing I did, I bought the book HTML for Dummies. Because at that time, it was not possible to build your own website in 5 minutes. You really had to start from scratch using HTML. Also, registering a domain name was only possible if you have your own company. So a friend of mine, he said, well, I like your idea, so I'll register xld.nl for you. And it came with a floppy disk, or a disk, which was really helpful, because that already gave me some ideas of what to do. So I started by just cataloging all the mutations in the ABCD1 gene. We had no funding, no sponsors, and no ads. And at the time, people said, why don't you put advertisement on your website? Because you make a lot of money. I said, no, I don't want that. So we just started, and this was my first version of the website in 1999. This is a typical previous century website. It contained all the mutations, and it had, in blue you see references to papers. And then it evolved throughout the years. It became a little bit more different, nicer. As I said, it had tables with mutations, and that was very helpful. But at that time, there was not a lot of information. We've heard many people say when you Google. If you now use ChatGPT or Google and you look for ALD, you find a lot of good balanced information. But in the beginning of the century, if you would type in ALD, it would be terrible what you would find, horrible. And it was only available in English. And what I noticed that if you have a website that is being used, then people know how to find you. So I was contacted from all over the world. So with the help of students and colleagues and specialists in different fields or areas of ALD, we wrote additional pages, and then we also translated them with the help from ILA Paris, or with students from Spain, or a physician from Germany. To make this information much more available for many other people. And we had a lot of visitors. We had more than 500,000 visitors in 9 years' time from all over the world. And I kept track of there were only 2 countries from which I had no visitors. It was really surprising. I'm not sure if they all were looking for ALD. So some of them probably ended up on the website, but for whatever reason. But there was also biochemistry on there, and we noticed that there was a lot of interest in the biochemistry pages. To give you an idea, I always say we publish papers, and then we look at citations, and we're really we're proud that with 100 people cite our papers. But if you look at these numbers, so here we have facts on ALD, and then the translation in Spanish. More than 70,000 people visit those pages and probably got information from there. I think this is really rewarding, and it gives us so much insight in the importance of providing good information. But until 2014, life for geneticists was fairly easy, because if a patient would visit the doctor, the patient had signs and symptoms that were suspicious of ALD. You could take a blood test, send it to the laboratory, measure viral fatty acids, do DNA analysis. If they both come back positive, the case closed. You have a positive diagnosis. But in 2013, 2014, ALD newborn screening started in New York, and then it extended throughout the United States and eventually also other countries. And population screening is really difficult from diagnostics. Because population screening, you measure everybody, and you look for a biomarker. And that biomarker is associated with an increased risk of a disease. But it doesn't prove that you have the disease. So it's a way to identify individuals with an elevated risk of a certain condition. But you need to enroll these individuals in follow-up programs to establish whether they are patients and when they will develop symptoms. So I also decided when I was at an ALD newborn screening meeting in New York, and Elisa Seeger, she was, well, I can say the grandmother of ALD newborn screening, and she asked me, this database, is this owned by the university? What is it? So it was clear for me that the people in newborn screening had no idea of this database because they come from a different direction, a different angle. So I decided that just putting mutations on there with references was not informative anymore. So I took on a challenge for myself. In 2017, I decided that I had to redo the database. So I went back in the literature from 1993, and I tracked down all the papers that reported patients with ALD. And there was 173 publications, and also had data from 13 diagnostic laboratories from all over around the world and physicians. And also what made it more complicating is that at that time still there were two number systems being used. And only one of them we use now. I won't go explain you what it means, but you see that there's a difference between 1 and 386. And the publications from the earlier publications, some of them were using the wrong number system. So I also took all those mutations and then I converted them to the correct numbering system. And also realized that in newborn screening, one patient is interesting, but if you have 10 or 20 patients with a particular mutation, that gives you more power that this is really a disease-causing variant. So I also counted cases. And with a case, I mean an individual who's been diagnosed with signs and symptoms of ALD and elevated by variant chain fatty acids, so biochemical confirmation. And I also realized that there are also many research papers out there in which people use skin cells from patients to do research. And if they mention the mutation and they measure any function of the protein, there's additional information. And you can also combine that information. So in 2017, a total of 2,642 cases had been described, or I knew of these cases, and these represented 799 different mutations. And then, because of all this information, I could also add extra information for each variant. And because there's no genotype-phenotype correlation, or a mutation does not predict the clinical outcome, there's no clinical information on the website. Not yet, because I think this may change in the not so far future. And then I decided, you know what, let's move away from xald.nl and let's claim adrenoleukocyte.info. And Ted van Geest is a friend of mine. He's an expert in building websites. So for a few beers and playing games, he helped me to redesign the website for free. And so the mutation table changed into this, and I will zoom into some. So here you see an example of two variants. It's not just numbers, but it tells you how many times a variant has been found with all the references to all the publications. And there's also experimental data. So the effect on the protein or the C26 lyase PC, what we measure nowadays for diagnosis. So it's much more informative. And last year, I realized that the database was already out there for 25 years. So that was a reason for a little celebration. And this is actually the photo from Hugo Moser and me, a little younger, in Kennedy Krieger, where we decided to start this database. And when he said, I realized it later, like about 20 years later, when he said, I support you, we got $2,000 from a charity, but it turned out that it was Hugo Moser himself who had bought a baseball bat from Cal Ripken from the Orioles, and that money that he paid came back. So, but I found that out, I think in 2018, and Moser told me. And what is, I mean, James had mentioned it, collaboration and data sharing, and I think this is the website is a perfect example of collaboration and data sharing, and of course anonymized data sharing. And I will exemplify this in these slides. So if in newborn screening a baby is identified with a variant in the ABCD1 gene, but it's never been seen before, there's no information if this truly is a pathogenic variant or a benign, harmless variant. So we call that a VUS, a variant of uncertain significance. So, so there's no information. And what we see now is that the family received this report and they are clueless about the future of their child. They often don't even know if the child is truly at risk of developing ALD. And what we see is that such a variant may be identified more often. And it doesn't matter if you have 1 baby or you have 5 babies, if there's no information, it still remains a VUS. But now you have 5 families with an unknown future. And what now happens if one of the physicians diagnoses an ALD patient with clinical signs and symptoms, with elevated viral intravenously and the same pathogenic variant? We know that this variant that's now identified in these babies will cause ALD. We don't know which form of ALD, but it is a variant that is at high risk for developing disease. So we have a clue that this is a pathogenic variant, but because it may still be an error, we call this a likely pathogenic variant. So we can reclassify this variant from a variant of uncertain significance to likely pathogenic. And so we update the website and give all the information. So if now in the future an independent patient is identified with the same variant, suddenly we have 2 sources. And now we know that this variant is pathogenic. So this gives inside information for all these families with a child with an unknown future. And so we can connect all this information and we can upgrade this variant to pathogenic. And this you can only do if you collaborate. So I think this is a perfect example that if we all work together, clinicians, researchers, diagnostic labs, and also trying to motivate all my clinical colleagues that if they publish a paper with a patient, put the mutation in there. And I won't curse. I don't like it if I read a paper and it says, yeah, we confirmed the diagnosis, but I'm looking for the mutation, it's not there. So what I also often see is that ALD families think that every condition, every disease has its own website, its own database, but that's not true. Actually, I only know 1 condition or 2 conditions with an actively maintained website, and one of them is ALD. So most diseases rely on ClinVar, which is really nice, but it has become a data dump, unfortunately. And I'd like to give you an example. Oh, I got to put in 1 extra slide. So what happens often is that genetic screening is a big market. So a lot of companies have jumped in this market and they offer a lot of screening. And luckily, many of them, they donate the variant information to ClinVar. But the chain from a doctor, for the patient and the doctor to the diagnosis, that chain has been broken because these companies, they don't have information, often they don't have information on the clinical status of the patient. So, and also we don't know in these companies who classifies the variants. Is there an expert review or are they using automated algorithms? So how is the variant classified and on what kind of evidence? And as I said, these companies don't often have access to clinical and biochemical supporting data. And also what I noticed is that most of these companies, they only use published information to classify the variant. And to give you an example, so these are all the missense variants. So these are variants in which 1 building block of the protein is changed. We call it a missense variant. And in ClinVar, there are, I didn't put them together, there are like 1,500 missense variants in ALD, and you can classify them in 5 genetic classes. Class 1, 2, 3, 4, and 5. Class 1 are variants for which we know there are changes in the DNA, but they don't cause disease, so they're benign. Class 2, they are likely benign. Class 5 at the bottom, these are pathogenic, so we know they cause disease. Class 4, the orange ones, it's likely pathogenic, so there's limited clinical information, but it's very suspicious that this is a disease-causing variant. And then the one in the middle, these are the variants of uncertain significance, the gray area. And if you can see, if I look at the data in ClinVar for ALD, almost 50% of the reports in ClinVar are variants of uncertain significance. And the increase in the number of VUSs, how we abbreviate VUSs, in ClinVar correlates with the expanding of the newborn screening. It means that so a lot of families in newborn screening receive a notification that a VUS has been identified in the DNA of their child. So it's unclear what the outcome is. And this is not only for ALD. So we see this for many, many conditions. And it has to do with the enormous increase in genetic testing. So what I did, I took the ClinVar information and I aligned it with the information from my own database. And what we see is that we see the numbers changing, and I'll walk you through it. So first of all, what we see is the number of VUSs. When you align the ClinVar information with the database, drops from 46% to 40%. The number of pathogenic variants increases from 20 to 31%. And the number of benign variants increases from 4% to 15%. You may say, so what? But if you break this down, it means that now instead of in 24% of the cases, there's certainty about the diagnosis. Now it's 46% of the cases individuals know that either their child does or does not have the condition. And so I think this exemplifies the power of working together and maintaining a registry like this. So it brings me to my last slide, and I hope I'm in time. So important, all ALD patients have a mutation or pathogenic variant in the ALD gene. And there's a very high number of unique variants in this gene. By now there are more than 1,250 different variants. And almost 1,000 of these are likely or pathogenic. And importantly, the mutations do not predict the clinical outcome. So they don't predict whether an individual will develop cerebral ALD, spinal cord involvement, or adrenal insufficiency. And also within a family. We know a lot of families with males with different clinical outcomes. Yeah, the ABCD1 variant registry is actively maintained through anonymous data sharing by clinicians, by labs, by researchers. Yeah, and it's one of the few conditions. ALD is one of the few conditions that has a database like this. And and it's only possible. A big thank you to all people who collaborate, either by donating variants, content, design, translations, ideas, questions, whatever. Yeah, thank you.
Thank you, Stephan. As you know, I've always been really interested in Stephan's database. One thing when we were talking at a conference in the States, I think, it became apparent that Stephan actually doesn't have very many, well, you've got one now for certain.
Yeah, I got one UK family.
Mutation. Now, it's very difficult for the UK to share your mutation with Stephan because of all the GDPR, etc., etc. I have shared my family mutation directly with Stephan, so I've sent him, the official letter says that he knows I'm not making it up. So I'm sure if anybody would like to get involved, and because it's anonymised anyway, I'm sure that people can reach out to you and share their genetic.
Yeah, there's a reference 200 and something that says information from families. Yeah. So it's not under your name, it's under the bulk of information that I receive from families, and often I'm first in contact with these families, and then they say, well, my brother, so you can actually count the number of cases in the family, and then we can just say this variant correlates with clinical signs, symptoms of ALD in a family. So others can see, okay, this is a mutation found in one family, and that is also informative. So it is very descriptive. And actually, that's all the information. So you can hack the site, but you won't get any more additional data than that's already there. There's no database behind it. So it's very safe.
Yeah,
I think.
And it's really helpful, obviously, because, for example, my mutation, Stephan didn't have. So, and clearly ours is a pathogenic variant. You know, my sons, my father, my cousin's got AMN, you know, so yeah, if you're interested, get in touch with me and then I can put you in touch with Stephan. Now, does anyone have any questions? Yep, Chris?
That was a fascinating presentation, Dr. Kemp, so thank you very much for it. I'm just thinking about the future, and in particular, we all hear so much about AI and how AI is going to be able to troll through, you know, billions of records of data very quickly, and fathom new answers to things. So I'm just wondering whether you doing anything on that realm of using AI going forward.
I'm a big fan of AI, especially when I sit at home, working at home by myself. I see AI as as I describe it to my friends, I see it as a bachelor student for native speaking, so speaks better English than I do, has some knowledge about what I do, but I cannot trust them every time, so I need to always be in control of the information. So AI is really, really helpful, and we use AI a lot because it also gives you new ideas, but we also use AI together with Triana, who her name was mentioned, because AI is also very good in, it's pretty good in predicting the effect of a variant on the protein. So it is an extra, so it's not 100% certain, but it gives you an extra level of information. So that's simply one example of using AI. And it's not so much AI, but machine learning, so neuronal networks, which is close to AI, but it's more controlled. We are using that because we generate so much data, because we ideally want to predict the future of an individual, the risk of developing the brain form or the spinal cord form. So we from our patients that my colleague Mark Engelen is seeing in Amsterdam at the Registry Center, there are more than 160 ALD patients. They participate in trials, and then so we do analysis in the blood on lipids. We are going to sequence the entire genome from all these individuals, because we know there are other genetic factors in the genome that contribute. We get MRI data, we get so much data, but it's so much that I cannot put it in an Excel sheet and look. So you need supercomputers to help you with, and that is, it's not AI, but it's machine learning. It's in that direction. So yeah, we absolutely are embracing it.
Thank you.
You're welcome. Oh, and in fact, the Amsterdam UMC has, so we have what they call a safe environment. So the Amsterdam UMC embraced AI very, very soon, and they have some contract that we can use AI, but it's shielded. It stays inside, so we can put information in there, and it uses AI, but it doesn't leave the institute. So just to promote the using of AI. So and you see many, many more examples. So I think it was 2 days ago, there was an example that AI is able to predict clinical outcome for certain conditions years before you would be able to do that by current measurements. So I think, yeah, this will really help in our research. There was a question over there, I think.
given that we've got such collaboration between the professionals, is there any reason why we can't share our mutation diagnosis? Is there a way that we can feed into that from the UK? I get that there's GDPR and all that sort of thing, but just considering how many professionals are all in the room, why we can't just say, here's ours.
It's not just the UK, but it's in many countries. It's becoming more and more. I think one of the reasons that this database is out there is that we started in 1999. And of course, I have all that information from that time, and I don't have any family names or patient names where I identify it, but I know that these were individuals. So I only have registered what type of ALD condition they had with the mutation. So that is valuable information that I maintained, and it's still there. And many is published, but yeah, so life was much easier until several years ago, and it's becoming more and more difficult. It's also, if we want to use data that we have produced in our diagnostic lab, and we want to use it to publish papers, we need IAB approvals just to retrieve the data, and you don't want to know how many questions these people in IAB can ask you, and then you wonder, where does this question come from? It's like, boop, oh, question. Luckily, I have several clinicians in my group who are willing to do this, because I think I can't. I think it has to stop eventually. It's not helping patients. It is blocking research. I think we're very close to say stop. I can ask a clinician his opinion, but
hang on a minute, Robin. Suzanne's just going to run.
You can do what you like with your own data. So as Karen says, there's no reason why you can't submit your data to wherever you want it to go. The problem is we can't submit your data these days without ethics approval. And I don't think we have an ethics approval for this particular database. So the leukodystrophy database you were learning about, you sign a consent in order to have your data put into that, and then the clinicians can do that. But for this sort of thing, as Stephan says, the number of hoops you'd have to jump through to be able to do that are quite a lot. So yeah, we can't share your data. You can. It's your data. You can do what you like with it.
We've got to wait for Lydia anyway.
I have to do Slido.
And we've got to wait. Lydia's in here in a minute.
Thank you. Hi, I would just like to say I'm very supportive of this database. I went to a lecture of Dr. Kemp's somewhere along the way and thought this is great. And I got my genetic diagnosis, the actual official piece of paper, sent it to Dr. Kemp along with the story of who in my family was affected, and did I need a doctor to talk to him, and he said, no, you're on the database now. So it's very simple. It's a great idea. I think we should support it.
Thank you.
Great.
Great.
Thank you so much, Stephan.
Yeah.